Today's basically a review day for the test. You guys remember the test is Thursday. But you do get, I am allowing you to make a sheet of notes. Again, standard size sheet of paper, like 7.5 by 11. Handwritten front and back is fine. Okay. I'd like that turned in before the test to me, though. If you have it today, I would take it today. It doesn't have to be right now. It could be at the end of class. It's fine. Or worst case scenario, you can drop it off like tomorrow during a community time or something is fine. Don't forget. But, like you put whatever you want on there. Formulas, equations, example problems, notes to yourself, whatever. Any and all of it's fine. Any questions about that part? Okay. So the test format, there's the standard 1 or 2 section test, 1 calculator, 1 no calculator. On the no calculator section, you'll have 4 multiple choice questions, like a question I wrote myself, and then a free response style question. And then the calculator part, 4 multiple choice questions and 2 free response style questions. Between the 2 sections, I'd expect to see 1 related rates problem on each section, either multiple choice or free response. I would expect to see like 2 to 3 L'Hopital problems total, 1 or 2 in each section. And the remaining problems I would expect to see like things dealing with critical values and inflection points and increasing and decreasing and concave up and concave down, average value, that sort of thing. The remainder of the topics kind of from 4.1, 4.2, and 4.3. Does that help clear any, organize anything what we need in our heads a little bit? Yeah, Violet?
Do we need to know the Lewis theorem or the mean value theorem?
So you should know, as far as theorems that I or the AP would expect you to have, are the intermediate value theorem, extreme value theorem, mean value theorem are 3 that you should know and be able to use and apply. Rolle's theorem, you don't need to have. The textbook really only uses it to prove the extreme value theorem, I believe, or the mean value theorem, one or the other.
Roots. It's the mean value.
Yeah. So it really only uses Rolle's theorem to do a proof, is why they introduce it. So those are the 3, big theorems that we've done so far that the IB or the AP or myself would expect you to. I would never ask you to write it, but you should be able to use it in context and not understand where it applies or where it doesn't. Is that?
Yeah.
Okay. Selena?
I feel like the related rate short answers it's like everything we went over for that, like fair game, because like the similar triangles and then like the Pythagorean theorem and like spheres and just like all that stuff we went over.
Yeah, I would say that the situations you'll see in your related rates problem would be familiar situations, so things you've seen before, whether it's like spheres or cylinders or cones or triangles or circles or squares or fairly straightforward. Aaron?
Are there gonna be like weird shapes? Like, and if so, will you give us like the whole hypothetical?
I wouldn't expect a weird shape. I would expect a shape of something that you've seen before. Your standard geometric figures, cone, cylinder, sphere, for or box from a 3-dimensional standpoint. Should be, nothing crazy. Like no weird troughs or anything. If you remember that homework problem, you're laughing because you do. It's like, oh, that was a nightmare. Okay. Other clarification stuff.
You don't have to memorize any volume.
I mean, short of like your standard, like 4 3-dimensional figures, like a box, a cone, a sphere, a cylinder. I wouldn't worry about any volume formulas past that. Is that okay? Okay. They're all basically just, scale factor, area of the base times the height. Okay. Do we have specific stuff we want to talk about? Review questions or homework questions? Things from the suggested multiple choice or free responses? Anything like that is fair game. Michael K?
Can we do 21 from the MCQs?
21 from the MCQs? Sure. All this going out. So it says, let f be a function with selected values given in the table above. Which of the following statements must be true? By the intermediate value theorem, there is a value c on the interval 0 to 3, such that f of c is equal to 10. Yeah. Is this not the right
I
one?
mean, is the 21 like the one above it? Yeah.
Oh,
I don't know if the numbering got messed up.
okay.
It's the one with the following functions of x is guaranteed by the extreme value 3.
Okay,
And interval is 0 to 4.
sure.
Yeah.
Okay. So this, whatever, it's number 20 now. I don't know what happened there, but whatever. So to use the extreme value theorem, what do we need? This is a case where if you don't have the theorem down on what you need to be able to use it, you're kind of sunk. So you need continuity on AB, and you need differentiability on AB, right? Is that it? Or is it just continuity? Just continuity, okay. So that's what I'm going to be checking for, is the continuity. So is tangent continuous from 0 to 4? No. Right? So if you think about what's the graph of tangent look like? Has a vertical asymptote, doesn't it? Where's that vertical asymptote at? Pi over 2. So is pi over 2 between 0 and 4? Yeah. So this one's out because it's discontinuous on that interval. Deal? Okay. Check the next one. Tan inverse. Is tan inverse continuous from 0 to 4? What's the graph of tan inverse look like? Looks like that, right? So that one should be good. Is this guy continuous from 0 to 4? Nope. Now, even though it crosses off, does that mean it's still a discontinuity though, right? It's just a hole rather than an asymptote. So that guy's gone. This, well, is the denominator Can that be equal to 0? Do the natural log of both sides. What's the natural log of 1? 0. That's on 0 to 4, so that one doesn't make it. Our only one should be tan inverse. And basically all I'm doing is checking for continuity. And specifically continuity on that interval, right? For example, if I had like this, that would be okay, even though it's not continuous. It is from 0 to 4 because its discontinuities are outside of that interval. So it could have been really mean in giving you things that were all discontinuous somewhere, but only some of them were landing in the interval that we cared about. Does that make sense, Michael? Yeah. Okay. And again, like, ideally we remember what some of these graphs look like to help us with that kind of a question. I know that's a tall ask because it's been a while since trigonometry, but Paulo. Same thing from the multiple choice? Okay. We've just done so many number 9s. If it's the wrong thing, holler at me when I put it in here. That's not what my number 9 looks like. Do I have the wrong thing here? Oh, I just have the wrong questions altogether here, apparently. Interesting. Okay, that's fine. Let's just do it this way then. Have to go back and look. Oh, I know what I could do. I'll do that after. Oops. Okay. So this is a limit question, right? So from now on, for every limit question I get, my first step is going to be check with direct substitution. So that would be f of 0 over g of 0, right? And in the problem, that tells me that that should be f of 0, 0, and g of 0, 0. That's one of those indeterminate forms, right? There's 7 of them. When I get one of those, it means that I should be doing a L'Hopital on it. Now, this one's already written as a fraction, so it's ready-made to go. To do L'Hopital, we just take the derivative of the top over the derivative of the bottom, and then we try to direct substitute again. So that would be f prime of 0 over g prime of 0. We're told that g prime of 0 is 1, and f prime is cosine. What's cosine of 0? That's 1, right? So I'm left with 1 over 1. So it should be 1. I think that's supposed to be an f prime there. Does that match what the key said? Okay. Thanks, Michael. I'm just looking at that guy and trying to decide if that's like a prime mark on the F or not. Do I have the wrong things pulled up here?
I think it's got like skip, and that's why all the blue numbers
Oh, interesting. I think 9 is not on there. Okay, well that's lovely. Okay. Well, Yeah, well, that's what we're going with. Assuming that's an f prime there. If it was f, then we do the derivative of cosine is negative sine and then plug 0 in, which would be 0.
Yeah, that's
But, then it would be 0 over 1, so it'd be 0, but like, whatever. You guys get the idea of how to do it, which is the important part, right? Yeah. Sure. Who's next? Yeah, Jenny. 3 from related rates. Yeah. Let's see, I got. It's the multiple choice ones. Okay. Boyle's law states that if the temperature of an ideal gas is held constant, then the pressure of the gas and its volume satisfy the relationship P is equal to K over V, where K is a constant. Which of the following best describes the relationship between the rate of change with respect to time of the pressure and the rate of change with respect to time of the volume? So all I'm going to do is just do the derivative with respect to time of both sides. The derivative of P with respect to time is 1 dP dt. K is a constant, so I can just pull that out. So I'm going to think about this as like kV to the negative 1. So the derivative of volume, or V with respect to time, is negative 1 V to the negative 2 dV dt. So if I just clean that up now a little bit, I get that guy. So it looks like, oops, D. Does that feel good? Any like deep sea divers in the room? Boyle's law is why you have to exhale on your way up, or else your lungs explode. Because you're keeping volume of the gas constant as pressure is decreasing, so it expands. Your head, basically your body explodes. So don't forget to exhale. You learned it in calculus class here. Next, others. I'm glad some people got some smiles out of this graphic, gory thoughts. Maria.
Can you do number 40
from 4.1, number 40. Yeah. So I'm going to grab the whole section so we have the directions here. Okay. All right. The directions ask us to find the critical numbers. So to do that, we need to look at the derivative. So the derivative of 4 minus tan theta, the derivative of 4 theta is just 4. And the derivative of tangent is,
negative.
yeah, secant squared. Okay. And then we need to set this equal to 0. Oh, well, we care about where the derivative is equal to 0, or where the derivative does not exist, assuming g does exist, right? Okay, so let's do the 0 or equal to 0 first. So I'll subtract 4 from each side. Divide by the -1. Square root both sides. And I'm not great with tangents, or with secants, but I can do cosines. I remember secant is 1 over cosine. And I don't want to do 1 over cosine, so I'll flip that. And in flipping one side, I have to flip the other. So I'm looking for where cosine is equal to plus or minus 1/2. I recognize 1/2 as a unit circle angle. Cosine of 1/2 is where the x is small. So that would be at pi over 3. And then over at 2 pi over 3. And then 4 pi over 3 and 5 pi over 3, I believe. And then where it doesn't exist, so that's going to be secant squared is the same thing as 1 over cosine squared. So this doesn't exist wherever cosine squared is going to equal 0. Which is going to be the same place as where cosine theta equals 0. But if I go back and I look at the beginning, tangent, I remember, is sine over cosine. So G is also is undefined where where cosine is equal to 0, right? So this doesn't matter, because any place where the derivative doesn't exist was only some place the function doesn't exist also. So that's fine. Okay? So our only critical value should be these guys here. Does that match?
Yeah.
Okay. Does that feel okay?
Would you have to do like the plus 2 and 5? Or?
Oh, sure. Yes. Yeah. Yeah. So that just means or anything coterminal, right?
Right.
Yes, absolutely. Was that the same? Oh, okay. Perfect. I probably wouldn't give you something that has infinitely many critical values. Unless it was a multiple choice question, in which case it would be there anyway, right? The 2n pi. Does that feel okay? I like finite things a little bit better. It seems like less crappy, especially if it's a no calculator question. I don't know that asking you to do a bunch of trig stuff is like super duper fair if you can't get partial credit out of it. Michael.
I don't think this one's, it might not be on your sheet. I can see on the answer one, but it's number 24 on that sheet.
Okay.
It's like if f is continuous for a is less than or greater than x is less than or greater than b in the differentiable.
Yeah, this question probably shouldn't have been on there because I see an integral symbol on there and we don't even know what that is yet. That's a poor choice by me. All right. So I recognize these as the conditions for the mean value theorem. This is the condition for extreme value theorem and also the intermediate value theorem, right? So this is the condition, or this is the statement for the mean value theorem. So that should be true. This is the condition for the extreme value theorem, as is this one. This one, though, this could be false, right? Does the derivative have to equal 0? Right? If I just think about, like, this is my function, continuous and differentiable, but the derivative of this is never 0. This, we haven't talked about what this means yet. I should have put this question out there. Does that feel okay? Yeah. So just reading the question, I start thinking, okay, well, what theorems are going to apply here? And then, like, okay, do I see any of the conclusions for these theorems? And that's kind of the way I sorted through that. Does that feel good? Okay. Who's next? Paulo?
Can you 22, please? It's your 20. It's a table.
Yeah, let f be a function.
Yeah. Function selected.
Yeah. Yep, that's good. Just wanted to double check before. I have the one from the one pulled up from the OneNote now, so I'm just pulling from that rather than the other file I had, which apparently is not the right file for me to be looking at. All right, let f be a function with selected values given in the table above. Which of the following statements must be true? By the intermediate value theorem, there's a value c on the interval from 0 to 3 such that f of c is equal to 10. That doesn't have to be true. Why not? We don't have that f is continuous, right? We just have f as a function, not continuous. So this could be false, right? Doesn't have to be true. Now, it could be true, but we can't guarantee it. By the mean value theorem, there's a c on the interval from 0 to 3 such that f prime of c is equal to -2. What are the conditions for the mean value theorem? Continuous and differentiable. Do we have either of those? Can we guarantee that that's true? No. Next, it says by the extreme value theorem. What are the conditions we need for the extreme value theorem? Continuity on a closed interval. Do we have that? No. So I would say none of these have to be true. So again, I'm just, as soon as I see those theorem names, I'm like, okay, what do I need to have to say this? If I don't have it, I can't say it. Right? For all we know, that this function f really just consists of these 4 points with nothing in between them. Right? That could still be f. In which case, like, we can't do boo diddly squat with it. Like. Sound good?
Yeah.
Sure. Who's next? Happy to do some more. I think this is valuable, having like conversations about these problems and stepping through of like, what am I looking for when I read this, right? Yeah, Michael.
This isn't like a question, like from the MCQs, but can we go over what inflection points are again?
Sure. So an inflection point is a place where the graph changes concavity from like concave up to concave down. So if I have a function that does this, that's going to be our inflection point. Because if we look, the graph is concave down, looking from there, and it's concave up afterwards, right? So our possible inflection points are going to be the place where the second derivative is equal to 0, and we have a sign change. In the second derivative. So for example, if f of x is let's say x cubed over 3 plus 5x squared over 2 plus 6x plus 1, and we want to find the inflection points. So I'd want to start by finding the first derivative. So that would be 3x squared over 3 plus 10x over 2 plus 6, or just x squared plus 5x plus 6. And then we'll find the second derivative, which will be 2x plus 5. If I set that equal to 0, I get negative 5 over 2. So I'll make a little sign diagram here. I'll choose a test value of x that's less than negative 5 over 2 and one that's bigger. If I plug that into the second derivative, 2 times negative 3 is negative 6, plus 5 is negative 1. And if I plug negative 2 in, 2 times negative 2 is negative 4, plus 5 is positive 1. So we've changed from positive to negative. I'll write that down here. So x equals negative 5 is an inflection point. Does that feel okay? The nice part about if you're dealing with polynomials anyways, each time you take a derivative of a polynomial, you end up with a simpler polynomial to deal with, which is pretty nice. Could be much worse. If you have like the product of an exponential and something else, it just gets worse and worse and worse. You know? Yuck. But polynomials we like to see. Violet.
So like with the negative and positive values, so the negative would be like concave down?
Yes.
Okay.
And the positive would be concave up. Mm-hmm. Very good. So I would expect like at least one of my free response questions to be like, here's a function, you know, find its critical values, where it's increasing and decreasing, find its, are those, you know, local mins or maxes, find the inflection point, where it's concave up, concave down. Like that screams free response question, right? Asking you to do like all that kind of analysis on it. You know, using your first and second derivative tests and checking where things are increasing and decreasing, concave up and concave down. And, you know, that's a textbook free response question, is to ask you to do a whole bunch of things that are all kind of interrelated. So I would expect to see that kind of a question as at least one free response. And you could do that, as long as I was careful, you could do that with or without a calculator, right? If it's a nice polynomial, You should be able to handle that without a calculator still if all you have to do is factor and stuff. You guys agree? It's not out of line? Okay. Just saying that might be a hint or something, you know, on what to prepare for. But the question like that polynomial I just gave you would be a good example of something that would be relatively easy to handle, doing all that stuff, right? Because if I look at the quadratic piece, that's factorable. You know, the linear piece of cake. Love seeing that. Yeah, you just have to remember to make sure you're using the correct, whether it's F or F prime or F double prime when you're doing your testing. What else? Yeah, Paulo. 72 from the multiple choice. It's a lot of multiple choices. There are some good ones in here, though. Let's look. 72. This is the one, right?
Yeah.
Okay. Let f be the function given by f of x equals x squared times the natural log of x for x greater than 0. Which of the following intervals is the graph concave down on? So I'm going to start by finding the second derivative. So to do the first derivative of this, notice that this is going to be a product rule. So I have x squared times the derivative of the natural log of x plus the natural log of x times the derivative of x squared. So the derivative of the natural log of x is 1 over x, and the derivative of x squared is 2x. So that's going to simplify down to x plus 2x natural log of x, right? So far, so good? Okay. Now I'll do my second derivative. So the derivative of x is just 1, but to do the derivative of 2x natural log of x, well, that's another product rule. So I'll have 2x times the derivative of the natural log of x plus the natural log of x times the derivative of 2x. So I have 1 plus 2x times 1 over x plus the natural log of x times 2. So 2x times 1 over x is just 2. So that's my second derivative. So I'm going to then take that second derivative and set it equal to 0. So I have 3 plus 2 natural log of x is equal to 0. So I'll subtract the 3 over and then divide by 2. And remember that the natural log is the same as log base e. And to cancel a logarithm, I do like the exponent base to both sides. So that's my potential inflection point. So remember, this is going to be like 1 over e to the 3 halves, right? So I need a value that's smaller than that and bigger than that. So a number that's smaller is going to have a bigger denominator. So let's just do like 1 over e squared. And a bigger number is going to have a smaller denominator. So let's just do like 1 over e to the first. Sound okay? So when I check then, the second derivative of e to the negative 2 is going to be 3 plus 2 times natural log e to the negative 2. I remember that log base e cancels exponent base e. So it would be 3 times 2 times negative 2. So that's going to give me negative 1. So same idea. So if we're looking for where we are concave down, we want this section here. So the problem said that we were for x greater than 0. So we're going to go 0 to x to the negative 3 over 2. So
You use that down. How do you get to? Is it because of the negative portion? Or because it equals to negative 1 when you plugged it in?
So I knew that this section is concave down because the second derivative is negative on that section. And because the problem says this only goes to 0, right? It says for x greater than 0. I know 0 is going to be the lower bound, you know, up to my inflection point. Is that okay?
So C, oh wait, no.
0 to, so that's A. Yeah, does that feel okay?
Yeah, a lot of steps, like I have to do that, but yeah.
Well, it's still the same problem as last time. What was worse this time was the algebra, right? And like remembering all your algebra 2 stuff on how to deal with logarithms and exponentials and doing it with no calculator. If you had a calculator, it would be, you know, so bad. But totally doable with no calculator at all. Which you're like, woof, Mr. Kulik. I know. What else you guys have? Happy to keep doing stuff if you guys still have questions about things, or we can talk about more generalities. You know, if you're like, I just don't know what to do with this or that or the other thing. Or can you talk about how to do this kind of problem again? You know, happy to do anything. Maria.
Can you just do number 5 from the FRQs?
5 from the FRQs? Sure. So I'm just going to copy the problem part of it and just going to skip like some of the preamble. So 5 reads, let f be a twice differentiable function where f of 1.5 is equal to 3. The derivative of f is given by the function f prime of x equals 7x minus 19 sine of x squared minus 4x plus 4 on the closed interval from 1 to 4. Part A says find all values in x on the interval from, or the open interval from 1 to 4, at which f has a critical point. Classify each as the location of a relative minimum, maximum, or neither. Justify your answer. So this is designated as a calculator active question, although I don't think I technically need one to do this. So worst case scenario, Maria, you could just type in the derivative that's given to us, set your window from 1 to 4 on the x, and just look for the zeros and just see, is it above or below, before or after the 0. I'm going to do it by hand also, just so you can see the difference. Is that okay? Okay. So f prime of x equal to 0. How do I know that I don't have to check for where the derivative doesn't exist? Yeah, it tells you it's differentiable, which means that the derivative exists everywhere. You could also look at this as polynomial, whose domain is all real numbers, times a sine function whose domain is all real numbers. It's got to be defined everywhere there also, right? Okay. So if I have this equal to 0, I can set each piece equal to 0 using like my zero product property. So one of my answers is going to be 19 over 7. Here we'll square root both sides to get rid of the squared on my sign. And then sine of 0 happens when sine is equal to 0 or pi. And I'm going to worry about both of those possibilities for right now because my interval is from 1 to 4. Now 0 doesn't land in there, but I haven't solved for 0 yet, right? So if I factor x squared minus 4x plus 4, and we'll square root both sides. So there's x equals 2. And then to do this one, this is just going to be a nasty boy. Well, actually, no, it doesn't have to be. We'll do the same thing. Square root both sides. Now here I have to be a little bit careful because when I square root both sides, I get plus or minus. So when I add the 2 over, I get 2 plus or minus pi. Yes, sorry, square root of pi. So this pi is 3 point something or another, right? The square root of pi is going to be less than 2 because the pi is less than 4. So if I take 2 and I add something less than 2 to it, it's still bigger than 4, right? If I take 2 and I subtract that number less than 2, that doesn't necessarily have to be bigger than 1, right? And in fact, I know that the square root of pi is somewhere between 1 and 2 because 1 squared is 1 and 2 squared is 4, right? So my only result is going to be this because that's less than 4. But if I have 2 minus pi, that is actually less than 1. So I don't need to worry about that one. Oops, I keep forgetting to write the square roots on there. Is that okay? Okay. So like, these are my 3 critical values, or potential critical values. So then I would just need to check these by making a sign diagram. I'm not going to do that by hand because quite frankly, it's now starting to get like ridiculous that I'm trying to do this by hand. But I could get the critical values by hand and that wasn't so bad. What happened to my calculator? What happened to my emulator? I don't want to search the web. I want to search on my computer. You stupid machine. Okay. So let's just, oh boy, I got a million things in here. So if I were to do this with my calculator now, so I'm typing it into the y equals. I'm going to set my window from 1 to 4 on x. And then I need my y's to be positive and negative because all I really care about is where it's crossing the x-axis. So I'll do that. So here at my first 0, that looks like a neither to me, right? Because it's going from decreasing and staying decreasing there. You agree with that, Maria? Actually, let's make this maybe just -1 to 1. It'll be a little easier to see. Okay. Do that again. So this one's a neither. This one is going from decreasing to increasing. That's a local minimum. And this one over here is going from increasing to decreasing. So that's a local maximum. Does that feel good? Okay. And you know that relative and local are the same thing, right? Okay. Use the line tangent to the graph of f at 1.5 to estimate f of 1.8. Okay. So in the problem, it tells me that, well, I know the slope for this tangent line is going to be f prime of 1.5. They gave that to me in the problem and told me that was 3. And my point that I'm going to use is 1.5 comma f of 1.5. Oh, I'm sorry. We're told that f of 1.5 is 3. Excuse me. To find f prime of 1.5, I'm just going to plug that in to the function for the derivative. Does that feel okay? Now, on my calculator, because I've already typed in the derivative into y1, I'll just do vars over to y-vars function y1 of 1.5. Okay. So my slope's like -210-ish. So what am I doing here? I'm really doing like a local linearization, right? And then I want to use that to approximate f of 1.8. So I'm just plugging 1.8 into this. So I go to my calculator. So take that number times 1.8 minus 1.5 plus 3. So I get about 237. Does that feel good there? Okay. And then it says on the interval, the closed interval from 1.5 to 1.8, the first derivative is negative and the second derivative is positive. Is the approximation found in part B an over or underestimate of f of 1.8? So I'm just going to sketch a little picture here to help me answer this. So let's say that's 1.5 and that's 1.8. So this part is telling me that the function is decreasing. And this part is telling me that it's concave up, right? So my function is going to look like kind of like that, right? So when I drew my tangent line, here's like 1.5 comma 3. I drew that through it, and this would be like L of 1.8. This would be like F of 1.8. Is it an overestimate or an underestimate? It's under, right? Because I can see clearly that L of 1.8 is less than F of 1.8. AJ, what's up?
Face the button.
Yes. Does that feel okay? So just kind of using, I just usually try to sketch a little picture and draw what's going on. Usually answers any question I might have about, is this an under or overestimate? Feel good so far? Okay, and then it says, using the mean value theorem, explain why the average rate of change over of f over the interval from 1.4 cannot equal 6.5. Okay. So mean value theorem, we know f is continuous on 1.4 to 1 to 4 because f is twice differentiable, and we know f is differentiable on the open interval from 1.4 because f is also twice differentiable. So the mean value theorem states there exists a c on the interval from 1 to 4 such that f prime of c is equal to the average rate of change and we're told that that value is supposed to be 6.5. All right, let's say this. Assume, for the sake of contradiction, that this guy is equal to 6.5. So if I take then 7c minus, or 7x, I plug c in for the derivative. Has to equal 6.5, right? So I know that sine squared has to be between 0 and 1, right? So let's just assume that it's 1, it's maximum value. So basically I need that 7c minus 19 has to equal 6.5. So if I add 19 to both sides, and then divide by 7, What do I get there? Six. Why would that be? But that's in 1 to 4. What did I do wrong here? Do you guys see it? You don't even know what I did. You're all being so quiet. All right, let's double check here. Let me pull this up, my answers, and take a look. I had to done something stupid here. Need to stop being stupid, guys. Okay. Yes. Oh. I'm so stupid. I forgot that we have our calculator. Maria, this is the trick. Look. And just change my y's enough so I can see it. So here's my derivative function. Here's 6.5. Is there a solution? So don't do any of this.
Would you just put like there's no solution on that?
Yeah,
Okay. Would there be a question like this on the test?
absolutely could be.
Or like not something you'd have to like do all before, right? Would it be like something like
Or it would be something even like if, let's say for example, just hypothetically, if the derivative just had like this part to it, here we know that sine is between 0 and 1, or sine squared is between 0 and 1, so clearly it can't equal 6.5. You don't even have to do anything more than that to tell it's no solution.
Okay.
Does that,
yeah, so it'd be
like if it was simpler than this,
okay.
you could do it with no calculator, right? Because it's a linear times a trig is what makes it like, kind of need the calculator to do it, because even when I tried to do it with no calculator, it's like, oh, maybe that is, what did I do wrong? Did that, are you happy?
Yeah.
Okay. Violet and then Michael?
Okay, so for that, this FRQ for A,
Yeah.
did you state like what values are the minimum and maximum?
So we did it when I looked at the graph. I didn't write it down.
Okay, so like, I feel like you could use a calculator.
Oh, it would not be this complicated.
Okay.
Because the reason I didn't want to do it is because when I plug 19 over 7 into this, I don't know what the heck sine squared of,
Yeah.
when I plug 19 over 7 into that, what that's going to be. I have no clue. Actually, I do. I know it's going to be a positive value.
Okay.
Right? So I guess I do. I know anything coming out of this is going to be positive. So all I really need to do is check when I'm plugging it into here, whether it's positive or negative.
Anything that's positive would be the relative.
You have to look at the sign change.
Okay, we would have to do like.
Yeah, you build a sign diagram. But I did this, since it was a calculator active problem, I just looked at it. I'm like, okay, this one is nothing. This one is a local minimum, and this one's a local maximum. Is that okay?
Oh yeah.
Okay, Michael.
Can you explain like the estimate part again, like the rest of it?
For part B?
Yeah.
Yeah, so it said to use the line tangent to the graph at 1.5 to approximate f of 1.8. You need to go. So I know that the slope is going to be the derivative, or the value of the derivative at 1.5, right? So I just plugged 1.5 into that function, typed in my calculator, and got my answer, negative 210. And I know the point is going to be 1.5 comma f of 1.5. In the directions, they told me f of 1.5 is 3. So I have the point 1.5 comma 3. So I just wrote my tangent line or my linear approximation as m times x minus x1 plus y1. And then I plugged 1.8 into it. And I got 237 on my calculator. Okay with that? Now to decide whether that was going to be an under or overestimate, it told me on the interval from 1.5 to 1.8, the graph is decreasing because its derivative is negative, and concave up because its second derivative is positive. So I just drew a picture of something that was decreasing and concave up, and then put a point at like 1.5 and drew my tangent line. Oops. So the end of my tangent line, that's going to be like 1.8 comma L of 1.8. And the end of my function is going to be 1.8 comma f of 1.8. And because I can clearly see that L of 1.8 is less than f of 1.8, I have an underestimate. So I just kind of drew a picture of the function, the tangent line, and like, oh, yeah, well, definitely an underestimate. There's no way to draw it so it wouldn't be.
So for like one of those, you just like draw a picture.
Absolutely, yeah. Yeah.
Just like explain.
Explain what you're saying. Yep. Yeah. The work that I did, I think, is excellent. Like a perfectly appropriate work. A very strong argument, right? I told you why drew the picture that I drew, because the parts were decreasing or concave up. Drew my picture, draw my tangent line, and show, okay, well, that approximation is less than the actual value, so it's an underestimate. Yeah, totally fine. Addie.
What's the difference between doing a line truss for conjugate?
So for the relative minimum maximum, you're using the first derivative. For concave up and concave down, you're using the second derivative. But it's the same process.
Okay.
It's just different part, different version, you know what I mean? One's first, one's second. Is that good enough? Mm-hmm. Yeah, no problem. That was a good in-depth one to talk about, right? And I think if I looked, what did I, FRQs? Yeah, if you look at number 6, Maria, it's like, let me just drag it over here real quick. It's virtually the same question, but here it's just sine of a polynomial. This one is, at least to do like the mean value theorem parts, totally doable without a calculator, right? Because this guy I know is locked between -1 and +1. So could it ever equal 1.25? No. And that's all the explanation you'd need to give, other than verifying the conditions for the mean value theorem and doing that stuff. But yeah, like a much easier solving, right? Because you can see it without having to like even do anything on your calculator per se, although it wouldn't be wrong if you did. Like on that previous one, if you did this on your calculator, just draw like a little sketch and say there's no solution on that interval, like totally fine.
We wouldn't need to use like the mean value theorem to explain.
You need to use the mean value theorem just to justify that this is the equation you need to solve. But that equation having no solution, you can just sketch a picture of the graph and then just be like, of course it has no solution. Look at the picture.
Okay.
That'd be totally fine. So we got like 10 minutes left here. Last calls.
We should probably know the answer, right?
I would say for the AP exam, definitely. For Thursday, I would think if you know the quadrantals, like 0, 90, 180, 270, 360, I think you'll probably be okay. Which are usually pretty easy to remember because if it's these 0 1s,
Yeah.
I was like, yeah, that's not so bad. Yeah, so if anybody has their sheet done and they want to turn it in and get rid of it, I'll be happy to take it. If not, write yourself a note to make sure you remember to come drop it off to me sometime tomorrow.
We just get it before the test.
Yeah, I'll hand it back to you at the test. When I hand out the test or whatever. Yes, of course. Okay. Oh.